All right, so this example here is a little bit trickier than the ones you've done, and there's also something I just want to cover off at the very start of the question as well in your first step. Okay, so we're proving by induction that 1 plus 3 plus 9 all the way up to 3 to the power of n. So that's 3 squared. So that's 27, 81, 243 are kind of your next ones in this series. If you add all those up, you can get it using this formula here. Okay, so usually our first step is P1. So I sub 1 in for n. But I told you the way to check that is make sure putting 1 in for n gives you the first term in the series. All right. If you sub 1 in there, 3 to the power of 1 is not 1, it's 3. So if you want to get that term there, it's actually 0 that you're subbing in. Okay. So it's P0 that we prove here. Sometimes they'll make that a bit more explicit for you, that it's not 1 you're subbing in, it's something else. Here you just kind of have to notice it yourself. So we are, first step, show P0 is true. So P0 is equal to, subbing 0 in on the right hand side, a half on 3 to the power of 0 plus 1 minus 1. So we know that P0, adding up just the first term here, is 1, is equal to a half on, that's just 3 to the power of 1, which is just 3 minus 1. So 1 is equal to a half on 3 minus 1 is 2. A half times 2 is 1. All right, so P0 is true here, and that's the first term in that series. So just be careful with that. And the way to check it is, if you sub 1 in there and don't get the first term in the series, it must be some other n that this thing starts at, and this one starts at 0. Next one, no different. Okay, so than usual is just to assume PK is true. So left hand side, 1 plus 3 plus 9 all the way up to 3 to the power of k is equal to a half on 3 to the power of k plus 1 minus 1. So it's just our question written out with k instead of n. And then we're going to try prove pk plus 1. So prove pk plus 1. So remember, that's the left hand side from here with the next step. So I would write that entire left hand side out in full. 1 plus 3 plus 9 plus all the way up to 3 to the power of k plus our next step, 3 to the power of k plus 1. And that's equal to, on the right hand side though, we're just going to sub in k plus 1 instead of k plus 1 instead of n from the question. So that is a half on 3 to the power of, so instead of k, I've got k plus 1. So it's going to be k plus 1 plus 1. So that's k plus 2 minus 1. All right, so next bit is the same as it always is. So up as far as there on the left hand side in what we're trying to prove is the same as the left hand side from my assumption. So I can sub this in. So instead of this, I'm going to write a half 3 to the k plus 1 minus 1, and then plus 3 to the k plus 1, and that's equal to a half on 3 to the k plus 2 minus 1. So similar kind of trick here that I used in a previous example. I've got a half here on the right hand side. I've got a half here in one of my terms on the left hand side, but not the other. Okay, so I'm gonna kind of artificially shove in a 2 over 2 here. So I'm going to multiply this term by 2 over 2. That's just multiplying by 1. So there's no need to, you're not changing anything. There's no need to do it to every other part of the equation. Either it is just multiplying by 1, so you can't just do that to one term in your entire equation. Okay, but what does it let us do? It lets us factorize a half out, so that I just end up with the half multiplied by something that I have on the right hand side. All right, so let's do that. Let's factorize the half out. Because looking at it, that's kind of, I'm going to see my minus 1 here. I can see 3 with powers, but they're slightly different. So maybe don't quite see how we're going to get the right hand side yet, but let's factorize the half out for a start and see where that gets us. So if I factorize a half out, I am left with 3 to the k plus 1 minus 1. Factorize out of that term there. And then if I factorize a half out of this term, I'm left with 2 multiplied by 3 to the k plus 1. So plus 2 multiplied by 3 to the k plus 1. And that's equal to my right hand side. Okay, so maybe not entirely clear quite yet how I'm going to get the left hand side to look like the right hand side. I've got my plus 2 there, seems to give me a problem. I've got my minus 1. I've got my minus 1. So I mean, what are we trying to do? I'm trying to turn this and this into this, because I have everything else in place. I have my half multiplied by, and I have my minus 1 as well. So what you'll notice on the left hand side here is you have 3 to the k plus 1 plus 2 times 3 to the k plus 1. Okay, so this is kind of like having 1x plus 2x. So you add these together, you're going to get 3 times 3 to the k plus 1. You have 1 of something here and 2 of something here. So when you add them together, you're going to have 3 of that thing. Okay, so just moving up here to finish that off. So a half on, so adding these together, I get 3 times 3 to the k plus 1, because this is like 1 times this. So 1 of something plus 2 of something is 3 of that thing. Minus 1. And then that is equal to my right hand side, my half on 3 to the k plus 2 minus 1. Now, you mightn't kind of get this step here unless you know what you're aiming for. You know you're aiming for k plus 2, so you must need to do something up here with the powers. Again, it's another like tricky one to spot, but the number 3, you can write that as 3 to the power of 1. Okay, power of 1 just is the same thing. So 3 to the power of 1 is the same as 3, so you're not doing anything there. Now you've got 3 to the power of something multiplied by 3 to the power of something. And you might remember from, you've been doing it all the way back in first year probably, if you multiply 2 numbers with the same base, you're allowed to add the powers. So 3 to the power of something multiplied by 3 to the power of something is 3 to the power of their powers added together. And if you do k plus 1 plus 1, that's k plus 2. And that's what we're looking for. So it's a half on, you can kind of write k plus 1 here and have your final step then, but I'll just write the k plus 2 here. So that's what I'm doing. I'm doing k plus 1 is k plus 2. Minus 1 is equal to a half on 3 to k plus 2 minus 1. So left hand side equal to right hand side. Conclusion then, so Pn is true for... So not just natural numbers here though, also 0. So you're going to put a 0 down here, will bring 0 into that set. Or you can say n is an element of n union 0, is I think how they write it in the book. Don't worry too much about that. Okay, that's just saying our solution works for the natural numbers, and then 0 as well. 0 is not included in the natural numbers. Okay, so don't worry too much about that. And I would say, yeah, this example is definitely on the trickier end of things. Plugging the 2/2 in there, so you could take the half out. That's something we've done before, and that's something you will use again. So that's something you should spot. The rest of it then is kind of tricky enough to get out, I would say. Another reason I wanted to do that example is just that the P0 instead of P1 that we've usually done. As I said, sometimes they might flag that for you in the question. So they might say for n is an element of n union 0. They might kind of point at it for you in the question. But here we had to kind of notice it ourselves, and I kind of went through that at the start.